Hi, my name is Will Lehman, and I'm the lead of HEC-WAT, and I'm here to talk about the difference between curve sampling in FDA and event sampling in HEC-WAT. Within HEC-FDA, as you've learned this week in your class, we define the four main relationships, or in this case, I've drawn the three main relationships at every impact area. And they are the flow frequency relationship, the flow stage relationship, and the stage damage relationship. We define those with uncertainty, and we sample off of them within each iteration of FDA. So it kind of looks something like this. So a random sample is made for each of those relationships. They are then composed together to create a damage frequency relationship. That damage frequency relationship is then integrated, and that's an estimate of EAD. We do that multiple times in a loop to be able to create a distribution of EAD. Each one of these estimates is spanning the probability range or the natural variability range, and each iteration is giving us an estimate of knowledge uncertainty. So when we look at the full range of all of the knowledge uncertainty estimates, we get a distribution of EAD. Within WAT, instead of doing curve sampling, what we do is we do event sampling. Each one of these relationships is represented by a modeling suite. So the parameters within that modeling suite make up this relationship with uncertainty. However, what we do is we don't exactly curve sample like you would see in FDA. We draw samples off of a probability range, and those events are bounced off of each model. So the models compute what their flows would be. Those flows are then passed to the next model to compute what their stages would be. So that, if you can imagine each one of those green dots being a RAS run with a shape set that represents that particular event. Then those RAS runs are then passed into some tool for consequences like HEC-FDA, which would then compute damage for each of those events. We take the events and we sum them together and divide by n. And that is a simple form of integration. As you have more events, as you go to larger numbers of events, you should get a better approximation of your estimate of EAD. We then run that in a loop, each loop consisting of a different set of events, each loop having different knowledge uncertainties sampled, which would define how those relationships actually work in each of the models. That would be changing parameters in the models, like in FIA, maybe foundation heights or structure values. And then we're able to, with all of those knowledge uncertainties combined together, create an estimate of EAD with uncertainty. So the difference between FDA and WAT is really, one of the differences is in the methodology comparing curve sampling and event sampling.